Hello guys, welcome on Tesla Eduventures. In this video, we are going to discuss the heat loss in capillary rise. So you can see that this is a capillary tube, and in this tube, when liquid rises up, then there is some heat loss which occurs in the liquid rise. So first of all, let us discuss the work done by liquid. So if we talk about the work done by surface tension, see, we know that the surface tension force will be acting like this in this direction. And the component of the surface tension force which will lift up the liquid is F cos theta. So we can say that work done by surface tension force is F cos theta into the height to which liquid is lifted up, that is h, and we know that F will be T into 2 pi r. This thing we have already discussed in the previous video, so we do not need to repeat this. So work done by surface tension force will be T into 2 pi r cos theta into h, and we can substitute the value of h as 2t cos theta upon r rho g. This formula we have already derived in the previous video. So work done by surface tension will be T into 2 pi r cos theta into 2t cos theta upon r rho g. Okay. Now, now, now work done by surface tension will be, this is 4t square and pi cos square theta divided by rho g. You can see that this is the work done by surface tension. Now you can also see that the potential energy of the water changes in the process, because this extra amount of liquid is being lifted up, and therefore it has some change in its potential energy. Now we can say that if this is a cylindrical column and the center of mass of this column will be at the height of h by 2, then we can say that change in potential energy of this liquid will be mg h by 2, where m is the mass of the water which is being lifted. So m will be the volume into density. Volume will be pi r square into h. Okay, density will be rho. This is g and this is h by 2. So you can see that this is pi r square into h rho. In fact, this is rho g h square by 2. And we know that h is equal to 2t cos theta upon r rho g. So we can substitute the value of h in this case. So delta u will be pi r square rho g by 2, and h square will be 4t square cos square theta divided by r square rho square. So cancelling this r square with r square, this 2 with 2. So delta u will be t square pi rho g cos square theta, and there is 2 also, divided by cancelling, there is g also, so g square. So cancelling this rho g, and there will be a rho g term in the denominator. So you can see that this delta u is 2t square pi cos square theta by rho g. Okay, and we have already derived the work done by surface tension, which was 4t square pi cos square theta by rho g, and this is 2t square pi cos square theta by rho g. Now we can say that work done by surface tension in lifting up the water is utilized into two forms. The first one is the change in potential energy of the water, plus the other one is the heat loss. Because you can see that change in potential energy of the water is just half of the work done by surface tension force. Therefore, some amount of heat is being lost in the process. So, heat lost can be written as 2T square pi C. What I have done, I have subtracted work done, I have subtracted delta U from work done by surface tension. So, this is delta U minus work done by surface tension minus delta U. As you can see that work done by surface tension is twice of delta U. So we can say that it would be 2t square pi cos square theta by rho g. This is the heat lost in the process of capillary rise. So in the next video, we'll be discussing some more important concepts of surface tension. Thank you.